In part one of factoring quadratics, you learn how to take a quadratic like x squared plus 8x plus 12 and use a method called the box and diamond problem. And eventually you do the work and figure out that it factors into x plus 6 in parentheses times x plus 2 in parentheses. Well, it turns out there's also some special cases or shortcuts that you can use when factoring, and that's what this video is all about. So with no further ado, let's get it on! Let's go ahead and take a look at the first special case. This one has 4x squared minus 25. The first thing you'll notice is there are no x's in this quadratic. So let's go ahead and add them in. So I put in a plus 0x here already. I've gone ahead and started the box and diamond problem, put 4x squared and minus 25 in these corners, multiplied them together, got that negative 100x squared, and put the 0x down here. So when you ask yourself what multiplies to be negative 100x squared, all the possibilities are over here. One's going to be positive, one's going to be negative. And in this case here, since we need them to add up to be 0x, it's going to be negative 10x and positive 10x. So let's go ahead and put that in here. So there's our positive 10x and our negative 10x. Going to write them back over here. It doesn't really matter which one goes where. And then to wrap this up, what we do is we say to ourselves, well, look at these two terms here. What do they have in common? What's their greatest common factor? Well, a 2 goes into both of them. So does an x. When we say 2x times what is 4x squared? Well, that would also be a 2x. Then 2x times positive 5 would give us that positive 10x. And then 2x times negative 5 gives us negative 10x. Therefore, our answer is 2x minus 5, 2x plus 5. So you've probably already noticed here that at the very beginning there was no x's. We have a minus in between them. You'll notice in our answer we have basically the same two terms, 2x and a 5 and 2x and a 5, except one has a minus, one has a plus. So let's talk about what makes this special and how we can use shortcuts here. So in this chart down here, we'll talk about some examples of what works and doesn't work and what the shortcut is. But what this super secret shortcut is called it's called the difference of two squares. So difference means subtract. So this method will only work when there's a subtraction like 4x squared minus 25. Plus each of the terms like 4x squared and 25 have to be perfect squares. That means that if we square root this, in this case, the square root would be 2x. And if we square root this one, it'd be 5. And those are the two terms that show up in each of the parentheses, one with a plus and one with a minus in between them. And this is kind of the generic version of what we're seeing there. So let's take a look at some examples here of what works and doesn't work. The first three do work, and that's because they're both perfect squares. For instance, x squared, the square root of that's x. Square root of 36 is 6. So yeah, you can factor it quickly into x plus 6, x minus 6. So you don't need the box and the diamond problem, you just know what it's going to be. Same thing on the second one. Square root of that is 3x, square root of this is 7, so it's going to be 3x plus 7, 3x minus 7. On the third one, square root of x squared is x, square root of this is going to be 2y, so x plus 2y, x minus 2y. The last two don't work. Here's why. In this one, we have a plus. Well, that's not a minus sign, so that's a sum, not a difference. And in the last one, 25x squared is a perfect square. However, 14 is not. So these two at the very bottom will not work. And in fact, they're not factorable at all. If you like what you've seen and heard so far, please like, comment, or subscribe. Thank you, and back to the show. We're going to go ahead now and look at the other type of shortcut. And this one is going to have three terms in it. So in this case, we have 9x squared, negative 12x, and a positive 4. Once again, I've gone ahead and already started. So 9x squared and 4 go in the corners here. 9x squared times 4 is 36x squared. And then we put the x's down here. So we're looking for two numbers that multiply to be 36 but add up to be negative 12. Well, the list of all things that multiply to be 36 are listed here. And in this case, they're both going to be positive, because we have to multiply to be a positive number, but add it to be a negative. So it ends up being the last one on here, 6 and 6. So it's going to be negative 6x and a negative 6x. So they're both the same. Interesting. Putting them back over here, we get negative 6x and negative 6x. What do these two terms have in common? Well, 3 goes into both of them. So does an x. 3x times itself would give us 9x squared. And then we have 3x times a negative 2 gives us negative 6x, and 3x times negative 2. So what do you notice here is, wait, they're the same on the side and on the bottom here. So we're going to get 3x minus 2 times 3x minus 2. And most people will go ahead and write this instead as 3x minus 2, and that quantity squared. So you might be asking yourself, well, what's the shortcut? Well, the shortcut is this is called a perfect square trinomial. So let's break down the language here. So what does trinomial mean? It means 3 terms. So back in this, we had 1, 2, 3 terms. And perfect square means that the first and also the last are going to be perfect squares. So the square root of 9x squared is 3x, and the square root of 4 is 2, and you'll notice the 3x and the 2 show up in the answers here. And then the final check is this middle term here has to be double it. So in other words, if you were to take the square root of 9x squared, which is 3x, multiply it by the square root of 4, which is 2, and if we double that, 2 times 3 is 6, 6 times 2 is 12. So yeah, it does double. So we have 12x up here. So that's how you can check to see if this works or not. The shortcut way, or more generic way of writing it, you'll see over here, where we have a squared and b squared as our first and last term, and we have plus or minus here, because this works. If it's a plus before the 2ab, it'll be a plus over here, and if it's a minus before the 2ab, it'll be a minus over here. So let's take a look at how this works and how it doesn't work. So on this first one over here that works, the square root of x squared is x, the square root of 36 is 6, so there's our x and our 6. It's a plus because we see a plus right here, and if we take each of them, if we take 6 times x and then we double it, we do get the 12x in the middle. On the second one, if we square root 25x squared, we will get 5x. If we square root 16, we will get 4. If we multiply those together, 5x times 4, we get 20x. And then if we double it, we get 40x. And you'll notice we have a minus here, so we should have a minus here. Let's show you a couple ways that do not work. So these last two do not work. Why not? Well, the first and the third term both are perfect squares. And if you square root them, you get 3x and 1. But if you double 3x times 1, you wind up with 6x, but there's only a 5x here, so that's not going to work. And on the last one, 4x squared is a perfect square, but alas, 8 is not. So that's how you can check quickly and then avoid having to do the box and the diamond problem. Not that the box and diamond problem really is such a bad thing, but this certainly is a lot quicker and, in my opinion, easier. Hope you enjoyed this video. There is a part 3, so hope you stick around for that. Thanks, everybody.